All right, let's dive right in. Today, we are tackling a pattern that shows up pretty much everywhere, from your dating apps all the way down to fruit flies. It's a mathematical rule that helps explain one of the oldest mysteries in the world, rejection. And believe it or not, it all started with a simple experiment way back in 1948. So, here's the big question that seems to break the internet every other week. Why do women, on basically every platform, reject something like 90% of men? And this isn't just about one app or one culture. It is a super consistent pattern, whether you're looking at speed dating studies from the 90s, historical birth records, or, the dating apps on your phone right now. So, what is really going on? Now, you've probably heard all the usual suspects, right? Maybe it's unrealistic standards from social media, or maybe it's feminism or capitalism, or it's just, modern dating culture. But here's the giant hole in all of those theories. This exact same pattern shows up in species that don't have culture. Female fruit flies behave almost exactly like women on Hinge, and I'm pretty sure they've never scrolled through Instagram. So, okay, if it's not culture, what is it? Well, the answer is mathematical. We're talking about a biological algorithm that's been running for, about 4 billion years. And it was first put into numbers in a lab full of flies. And that brings us to the first huge clue in this whole mystery, a landmark experiment from 1948. This is where a scientist named Angus Baitman took something everyone had kind of noticed and turned it into cold, hard data that would totally change how we understand attraction forever. So just to set the scene, before 1948, pretty much everyone accepted Darwin's idea that males compete and females choose. I mean, you can see it with peacocks, with deer, it's obvious. But it was just an observation, It wasn't a proven mathematical rule. And that's what Bateman wanted to find. He wanted to give Darwin's poetry an equation. And what he found was, honestly, stunning. When he tracked how many offspring his fruit flies had, he saw two completely different stories playing out. For the males, it was this high-risk, high-reward, total boom or bust game. A few males had tons of offspring, over 100, while a whole lot of them had 0. But for the females, their success was incredibly consistent. It was stable, it was predictable, almost all of them had offspring, and the numbers were all clustered together. But Bateman didn't just stop at counting. He actually plotted this data on a graph, and when he did that, boom. He discovered a fundamental mathematical rule that seems to govern mating behavior across countless species. He called it the Bateman gradient. Okay, check this out, because this is where the male strategy becomes crystal clear. For the male fruit flies, every single additional partner led directly to more offspring. You get one mate, you get about 20 babies. 2 mates, you get 40. 4 or more, and you're hitting a massive reproductive jackpot. See that? It's a steep climbing line. For them, more is always better. But for the females, the story is the complete opposite. After that first partner, maybe the second, adding more mates did almost nothing to increase their number of offspring. The line goes almost completely flat. The reproductive benefit just wasn't there. It was actually a waste of their resources. So this right here, this is the Bateman gradient. It's like the mathematical signature of sexual selection. The sex with the steep gradient, in this case males, is going to compete for quantity. And the sex with the flat gradient, females, is going to become incredibly choosy, focusing on quality. And listen, this isn't a personality trait. It's a mathematical imperative. Okay, but that just leads to the next question, right? Why? Why are these two lines, these two strategies, so radically different? Well, to understand that, we need to look at the basic economics of reproduction, right down at the cellular level. And this table just lays it out perfectly. I mean, think of reproduction as a marketplace. The male investment, sperm, is biologically cheap. It's tiny and it's produced at a staggering rate, about 1,500 per second. So the strategy is quantity. But the female investment, the egg, is huge. It's packed with nutrients and it's incredibly limited. A human female has only about 400 in her entire lifetime. The strategy has to be quality. This quote really makes it all click. Imagine you're a baker and you have a strict lifetime limit of 400 loaves of bread. You are not just going to give them away to anyone who walks in the door. No way. You're going to be extremely selective about who gets your bread. Your bottleneck isn't getting customers. It's your production capacity. That is the fundamental economic position of the female in biology. Okay, so this all makes perfect sense for fruit flies. But what about us? You'd think that with our big brains and complex cultures, we would have escaped this ancient pattern. But the data shows We haven't. Not even close. The exact same mathematical rule is playing out right now, from our ancient ancestors all the way to our dating apps. And the evidence is it's overwhelming. You look at historical birth records from places like Finland and Gambia, and you see male reproductive success was 2 to 4 times more variable than female success. Modern speed dating studies show women are 2 to 3 times choosier. And this is fascinating. A woman's selectivity literally peaks during ovulation, right when that limited resource, the egg, is actually on the line. So what does this look like in the world today, right on your phone? It looks like this. A female swipe right or acceptance rate of just 5 to 10%. That is a 90 to 95% rejection rate. It's the flat gradient in action, high selectivity, extreme quality control. And for men, well, is the steep gradient. A swipe right rate of 50 to 60%. It's a quantity-focused, cast a wide net strategy. You're literally watching 2 different mathematical programs play out in real time with every single swipe. And if you want to see the most extreme example of that steep male gradient, the boom in that boom or bust strategy, look no further than Genghis Khan. We're talking about one man whose Y chromosome is now found in an estimated 16 million living descendants. I mean, that is the ultimate jackpot of the male reproductive strategy. So what's the final verdict here? When you put it all together, that 90% rejection rate isn't some bug in modern dating. It's not personal, and it is definitely not new. It's actually the core feature of a 4 billion-year-old algorithm. And knowing that lets us completely reframe how we think about rejection. So here's the big takeaway. That left swipe isn't a personal attack. It's portfolio management. It's a risk aversion strategy that's been written into our DNA over billions of years. And it's based on the simple economics of a very high-cost, very scarce reproductive investment. At the end of the day, it's just the math playing out. And all of this leaves us with one last big question to chew on. If something as personal and as emotional as romantic rejection is actually governed by a cold biological equation, what else in our lives, the things we assume are cultural or psychological or just personal, what if they're actually mathematical? What other hidden algorithms are running our lives?